All right, so today is the day 2 of the lesson we were doing, and so it's the essential question is how do I evaluate and graph functions this time? So how do I evaluate and graph functions? Write that down,
Write
please.
that down. So before we get into the lesson a lot, we're going to talk about what do we mean by discrete and continuous function. So if you look at this graph here, all of these, there's points, but they're not connecting the dots.
Okay.
When it's a discrete function, none of the points will be connected.
All right, so I'm just writing no points connected for discrete.
Right, and that's because in between the points, the value of the values, I'm going to say, are undefined. That's why it's not continuous. It's only defined where the points are, and that's it. Anything in between is considered undefined.
And we'll do an example.
We sure will. So here's continuous. Miss Boyd is going to draw an example of a continuous function. And basically, it's easy as that. It's a line.
Okay, and just a reminder, continuous has the word continue. It keeps going.
Yes.
So that's how I remember it.
There's no breaks in the graph.
Okay.
Here's our example. Example number 1. We're going to graph a function. Typically, we're going to give you a rule that really you can use when you have a function and it's not saying anything's undefined. You're going to assume it's going to be continuous. It's a line. It's going to be a line. So how we're going to make the line is we have to first make a table. Now, we're going to just arbitrarily pick some x values that are easy to pick.
Meaning we can pick any number
you want.
Okay.
So let's start with, I'm going to say I want to pick some negatives and some positives. So how about -1?
Okay.
That's always a nice number.
Yeah.
So now we're going to use what we used in day 1 is we're going to use -1 as our input.
Okay.
Into the 3x minus 1
we're
function.
Plugging it in. So
right.
We have 3.
Yes.
Oh, instead of x, let me start over. I don't want my parentheses there.
No.
So I have 3 instead of x.
Right.
I'm plugging in negative 1. And then -1.
There we go.
Well, 3 times -1 gives me -3 minus 1.
And that's going to be
-4. -4.
That's our output.
Our answer.
There you go. We just right now generated a point.
Okay.
So maybe next to that you want to write the point, -1, -4. All right, let's try 0. I love 0. 0 is so easy.
Very easy.
So if we plug in 0 for x.
3 times 0 minus 1. Well, that's 0.
0 minus 1
0 minus 1 gives me -1.
There's our output. And there's our second point. 0, -1. How about 1?
Well, that's an easy one too.
Yeah.
If we tell you just to plug in any number, those are your easy numbers you're going to want to do because they're super simple.
Right.
3 times 1 is 3, minus 1
is 2.
Gives us 2.
That's our output. And there's our third point.
All right.
And really all we need is 3. You can keep going if you want, but we're not going to.
Okay, so -1, -4, go back 1,
and down 4.
1, 2, 3, 4, put my point.
And then how about 0, -1? We'll change to blue.
0, -1.
And 1, 2.
And over 1,
up 2. And now we can draw our line.
Let's see if I can do this. Ah, it's really hard with this. Oh boy. Just imagine that's a straight line. I'm going to try one more time, but it's really hard with this pen.
I know.
Slate. That was a little better.
Yeah, that's good. Right. I think they can get what we mean.
Draw your straight line.
You're supposed to connect the dots.
Yes.
Well, now that is, let me go back. That is a continuous function. Now we're going to do an example that we have a discrete function.
Okay.
Notice we're not given an actual value of a function with an x value. We're doing a mapping here. So let's just create our points right away.
Sure.
So we have an x and y. So the 3, 5, 7, 9, there are x's. So maybe put x, yep, there you go. 5, 7, 9. And it's showing that 3 is mapped to 2.
Okay.
5 is mapped to 6. And notice 7 is mapped to 10. And 9 is mapped to 10.
Oops. So that's okay. That's still a function.
That's still a function. Correct. And why is it a function?
Because we have exactly only one x value.
Correct.
It doesn't matter if our y values.
Correct.
Just like my mailbox. We have a piece of mail going to 2 pieces of mail going to the same mailbox. That's okay.
And Miss Boyd's going to really like this one because she doesn't have to draw a line because it's discrete.
All right, so
So-
1, 2, 3, up 2, put my first point.
Yep, over 5.
Up 1, 2, 3, 4, 5, 6.
Yes, there we go.
And then over 7, up. So there's 6, 7, 8, 9, 10.
Mm-hmm.
And then over 9. Did I count wrong?
Yeah,
Oh, boy.
1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5,
3,
6,
4, 5,
6, 7. One more.
7, up 10.
Yep, and over
And then
9
9
up
up
10. There you go. That is discrete.
So we don't connect the dots.
Correct, we do not. All right, next page is, our favorite thing of
Word
all.
problems.
Miss Boyd and I, we love word problems, right?
Yeah. But this one is okay. It'll
Okay.
be simple. We'll explain it. You'll get it.
So a carnival charges a $5 entrance fee and $2 per ride.
Okay.
We are going to write a function to represent the total cost after taking a certain number of rides. So the first thing we have to do, you have to define variables.
Mhm.
So what, for the fun of it, let's use R, because we're going on rides.
Rides.
So R is equal to the number of rides.
Number of rides.
Yeah, just to make sure everyone's
Yeah.
clear.
Perfect.
And then let's do one more variable here, C, because we're going to
Okay.
use that uppercase C, and that looks good. That's total cost in dollars.
All right.
Okay, our entrance fee is constant. So we are actually now ready to write our function.
Okay.
So our function's going to be C of R. Just like
Okay.
we did F of X, we're going to use C.
C
And then in parentheses R.
of R.
And if we wanted to, we could have done F of X. It doesn't matter.
Okay.
But I'm trying to put a word problem with a letter
The
so we can
letters,
know
that makes
C
sense.
represents cost.
Okay.
So our function is going to be 5, because that's our flat fee. That's our constant.
Yeah, we have to pay $5 to get in.
Correct. Plus 2R.
And every time I see per,
Mhm.
that reminds me that I'm usually going to multiply by something.
Yes.
So my 2 times my R, because it's per ride,
Mhm.
$2 for every ride. So if I rode 3 times, I'd have to times it by 6 or 2
Two.
and get 6.
Correct.
If I rode 4 times, I'd times it by 2 and get 8. And then you always add it to the fee you have to pay to get in.
Correct.
Okay.
So if you go, now that's done. That's the first part.
Oh, that's
But
a function.
now Miss Boyd is actually, she's so smart. She's moving ahead of us right
oh,
now.
boy.
Because look at Miss Boyd.
Oh,
What is the cost if you go on 8 rides?
well, we just
So
plug it in for
right. So
R.
what does 8 represent?
That's our R.
That's our R. So
Nice.
I'll float down a little for you. There you go.
She's moving it as I'm writing. All right, that's our R.
Okay.
So our cost of 8
rides. Here we
equals
go.
the 5 plus 2. Plug in that 8.
Again, we're using an input to generate
Our
an output, which is
All right.
cost.
So then we get
5
5 plus
plus
2
16.
times that is 16.
Well, 5 plus
So
16 is
cost of 8 is
$21. We need a little dollar sign because we're finding cost. That's it.
Nice.
So if I find my little next page,
Yeah.
do we want to go on or should we let them?
You know what?
Should we
Let's
do
do
this
this
in
one in
class?
class.
All right, let's
We'll
do
make it a
it.
short video this time again.
Here you go. Ooh.
All right. So we gotta just quick scroll
Yeah,
for you
so-
that you can see.
So it says graph the function.
Yep. So it does say graph the function, and here are your possible
There we go.
answers. So if you need to pause it to look at the graphs,
We'll just float down
we'll
one more
kinda,
minute for you
float
and then
down.
we'll float back up and
There
then
you
number
go.
2 is a word
Perfect.
problem for you to try.
All right.
Okay?
See you tomorrow.
Bye.